Alkis. So today we are in the University of Montreal and we're in the new campus called MILE.
We are here to interview Henri Charette, who is a chemistry teacher and who is the chairman of the chemistry department here at Université de Montréal.
Introduce yourself. What is your name and occupation?
My name is André Charette. I'm professor of chemistry at the University of Montreal. I'm also the chairman of the Department of the Chemistry for another year.
To begin, can you name us some commonly used solvents that aren't green solvents, and what are the negative impacts of them?
Oh, and I didn't tell you in the first question, but I'm also a specialist in organic synthesis.
Okay.
So we are developing new synthetic methodologies that can be applied to the drug synthesis. And one thing that we've been using for a long time are solvents such as benzene, toluene, tetrahydrofuran, dichloromethane, and many of these solvents, which are all petroleum-based, are rather either toxic, highly flammable, and they're not that convenient to use. But traditionally, in organic synthesis, people have been using these solvents for years.
Okay. What are the negative impacts of using these?
Well, there are several negative impacts. First of all, some of them are really toxic.
Okay.
Some of them are highly flammable. They are not quite compatible with the environment. In other words, they're not going to be biodegradable very easily. Although the most of the big companies nowadays are trying to recover as much as possible the solvent they're using, but still they can be harmful for the environment.
Okay.
Based on your research and studies, can you give me a complete definition of what green solvents are, and more specifically plant-based solvents, and how they are better for the environment?
Well, plant-based solvents are obviously obtained from nature, and ideally they would be obtained from the biomass. And in other words, first of all, you have to understand what the solvent is used for in a synthetic transformation. The solvents typically has several roles. The first role is to solubilize all the reaction components. You need because in a reaction, in an organic reactions, the reagent and the substrate will have to come together and react. So the primary role of the solvent will be to solubilize everything to make sure that the reagents are actually going to see in solution the reagent or the substrate they have to attack or react with. So that's the first role of a solvent. The second role of a solvent is to, I don't know if that's going to be too complicated, but it's to decrease the activation energy of a reaction. In other words, it will facilitate the reaction. So for example, if in a reaction you have a reagent and a substrate that will react, and these are partially charged, the solvent will be used to stabilize these partial charge in the transition state, so they will basically favor a transformation. So typically the solvent I referred to earlier on are traditional solvents that are well known in terms of polarity, how polar they are, whether they're non-polar or more or less polar, but they are also going to be able to stabilize the transition state depending on the type of reactions you're using. So typically the solvents from biomass, I mean the most common solvent that you can think of that is environmentally compatible is water. So a lot of people are trying to use water as a solvent in organic transformation. But the problem is organic molecules are typically hydrophobic, so they're not soluble in water. So that could be a problem. So in order to make a sort of a water that would be more compatible with organic reactions, one can use methanol or ethanol. So ethanol basically can come from the biomass. The most obvious example is for example, vodka, which is obtained from plants. So typically using fermentation, one can produce ethanol very cheaply, and ethanol is a pretty good solvent for a lot of different things. So that would be perhaps one of the perfect solvent for that would come from biomass. Unfortunately, ethanol is not perfect because it has an OH group, so it has an acidic proton, and for a lot of organic reactions are not compatible with acidic OH group. So for that reason, a lot of people have tried to focus on different kinds of solvents. One of them is a solvent called 2-methyl tetrahydrofuran, which comes from furfural, which comes from the biomass. It's a several transformation, but 2-methyl tetrahydrofuran is very similar to tetrahydrofuran, which has been used traditionally in organic synthesis. And that would be one that does not have this OH group and would be compatible with a lot of reactions. Another example would be ethyl lactate. Everybody knows about lactic acid. When you train and everything, you're creating lactic acid. So lactic acid is very cheap. If you react that with ethanol, you can generate ethyl lactate, which is another solvent derived from the biomass. And that one has been used also in some reactions. The problem really with solvents that are derived from biomass is that we have pretty much to reinvent a lot of methodologies or organic transformation. The reason for this is that organic transformation or solvent or the efficiency is solvent dependent. And if you change the solvent, then you have to re-optimize conditions to do a transformation. So if you're going to take, for example, a reaction that would be carried out in ethyl acetate, which is a petroleum-based solvent, and then you replace that with ethyl lactate, then you have to recheck everything to make sure that things are going properly. So a lot of things have to be, if you look at the literature, a lot of papers out there are just basically taking well-known reactions in a non-biomass derived solvents and try them out in biomass solvent to see if they work.
Okay.
Yeah.
A few examples, okay. Would you believe that these green solvents are economically advantageous? Would it cost less than the solvents we are using now?
Well, the problem is really that the petroleum-based industry is very well optimized for reducing the cost of producing whatever solvent you want. So finding biomass-derived solvents that will be available for as cheap as the other solvents that are currently used is going to take a lot of time because the petroleum industry has been going on for years and decades and decades. So all the processes are very well optimized, very well optimized for making a lot of different things, a lot of different solvents. So it's going to take time for to get the equivalent using the biomass. So I think if you look at that, a lot of countries have been trying to generate biofuels from the biomass, like ethanol, for example, and the costs are getting lower and lower, but it's going to take time so that whole process will become competitive with the petroleum industry. So I think it's just a matter of time, matter of optimization, and a matter of the need of the population to use these solvents, and then obviously the cost will go down. It's probably a lot like if you look at the electric cars these days, the first one were extremely expensive, and now they're getting cheaper and cheaper.
What are the health benefits that we would gain from using green solvents? Can you give us some examples?
Well, the first obvious examples is a lot of these green solvents are also biodegradable. I think that's really the first key issue because if you look at many of these solvents, they will react with UV light in nature, so they will decompose into really harmless compounds. So I think that would be the major advantage of this. Reduced toxicity is another one. So if you're going to use on a, let's say, in a pilot plant and you use reactions on a ton scale, and you're going to be using a green solvent, then it's going to be a lot better for the environment and for people, because if for whatever reason an accident happens, then you're not dealing with highly toxic material. And these materials are also biodegradable, either through UV light or through bacteria or enzyme or all these kinds of species, and they are converted into harmless materials. So I think that's really probably the biggest advantage. And also that they're not petroleum based, so eventually plants are always going to be there, and you can grow more and more of them if you need more and more of these solvents.
We've been using the word plant-based a lot. Is there another way we could name them? Like other terms
well,
used
typically
instead?
people use the term biomass.
Okay.
That includes pretty much anything that is bio-related. It could be plants, it could be, how do you say that, like shrimps in the ocean. It could be all kinds of different bio-related starting material that people are going to be using to create compounds.
How are plant-based solvents made exactly?
Oh, there are several ways. Fermentation is one way, and like this is the way ethanol is generated, is by fermenting plants. Ethyl lactate, it's the other way you can generate this is that, for example, you can take lignin or cellulose, which is a polymer, and then if you cook that with acid, that cellulose is degraded into a furfural if the conditions are right. And furfural can be used as a solvent, or it can be converted into other similar molecules that are solvents as well. So basically, there's a chemical transformation is another way. So you take very cheap reagents, you treat the biomass with those, and then that generates through heat or all kinds of different methods that generate solvents. So fermentation is probably the main way, as well as chemical transformations. The two main ways of generating solvents from the biomass.
Okay. We have one question left. We skipped it by accident.
Yeah.
If we replace the traditional solvents that we are using now for the plant-based, what are the advantages on the environment that we would be able to see or notice?
All these solvents are biodegradable.
Yeah, okay.
So it's basically easy. Traditionally what people have been doing is that if you do a chemical reaction with a solvent, you try to recover your solvents as much as possible and you reuse it. But in the case where that's not possible, then obviously these green solvents are biodegradable. So they're not harmful for the environment.
Okay, well, we'd like to thank you very much.
My pleasure.
We went through all of our questions.
Thank you very much.
Thank you for your time.
Yeah.